This is video lecture number 3 for chapter 12, and today we're going to look at liquids and solids. Like gases, the particles of a liquid are in motion, but unlike gases, the particles in a liquid are strongly attracted to each other. Again, these attractive forces between molecules are called intermolecular forces, or intermolecular forces of attraction. We also call them IMFs, and they're also called IFAs. But they both stand for intermolecular forces of attraction. The particles of a liquid vibrate, they spin, they move from place to place. All these motions contribute to their average kinetic energy. Even so, most of the particles do not have enough kinetic energy to overcome the forces of attraction holding them together, so they stay together. Because of this, liquids have certain properties. Liquids are much denser than a gas, and a liquid cannot be compressed. Liquids are fluid. They can flow past each other. They can diffuse, which means they mix together, just not as easily as gases. They take the shape of their container, but they will not fill a container if the container has a larger volume. So they essentially settle to the bottom of the container. Viscosity is a measure of the resistance of the liquid to flow. Honey has a higher viscosity than water, which means it's less likely to flow. Solid. A solid has just as much kinetic energy as a liquid at the same temperature. The difference is that a solid has a much stronger force of attraction. Therefore, solids will vibrate instead of move by each other, but that vibration is still kinetic energy. Since solids are more closely packed together, they are almost always more dense than the liquid phase, and therefore they will sink. Solid benzene will sink in liquid benzene. The one very important exception to this rule is water. Hydrogen bonding allows water molecules to spread out and to be less closely packed. So here is the structure of ice. You can see the water molecules and how they can spread out as opposed to water. Therefore, ice, solid, H2O, will float on liquid, H2O. And this is extremely important because in the northern climates like us, when winter hits and the water freezes, the frozen water, less dense, floats to the top and forms a protective layer. This keeps the water from underneath from freezing, and it allows fish and other sea life to survive the winter. So this is the ice, and these are fish. So now we're going to look at categories of solids. At room temperature, we have compounds that are gases. We have some that are liquids, and we have some that are solids. The properties of the compound depend on the type of bonding it displays. So it could be ionic, or it could be covalent. If you're covalent, you are molecular, and only weak attractions between molecules need to be broken. So we have what are called molecular solids. They have large molar masses, so that the weak attractions hold them together relatively strongly. They are poor conductors of heat and electricity, and the one I think of the most is wax. If you think of wax, you have a molecular solid. Wax is relatively soft, it melts at low temperatures, but it is considered to be a solid. Remember, we talked about a covalent network. Solids in which all the atoms are covalently bonded to each other throughout the entire molecule. Diamond is an example of a network solid. Silicon carbide was another example we talked about. They do not melt until temperatures of 1000 degrees or higher. So this is an interconnected network of covalent bonds that hold the molecule together. Ionic solids are positive and negative ions held together by the attraction of opposite charges. They are hard, brittle, they have high melting points, but remember, they conduct electricity when melted or dissolved in water. Metallic solids are positive ions in a sea of mobile electrons. They're malleable, ductile, good conductors of heat and electricity. So in a metal, we have positive ions, and then around the positive ions are electrons, so that they are neutral. But the electrons are free to move around to other ions. And then in an amorphous solid, the particles are not arranged in a regular geometric pattern. They form when molten material cools too quickly. Glass, rubber, many plastics are amorphous, so they don't have a geometric pattern. So here's a quick summary of our types of solids, and that finishes today's lecture. So have a great night, and we will see you tomorrow.